You know, in the programming world, you've got your superstars, the languages you see everywhere. But then there are the ghosts in the machine. They're languages you rarely see, but their influence, oh, it's everywhere. And today we're going to pull back the curtain on maybe the most famous ghost of them all, Haskell.
All right, let's get real for a second and look at the hard data. If you check out GitHub, which is, one of the biggest hubs for code on the planet, Haskell barely even shows up. We're talking less than 1%. It's practically a rounding error. So you're probably thinking, okay, why are we even talking about this?
Well, because here's the wild paradox. While almost nobody is writing code in Haskell, millions of us are using Haskell's ideas every single day, and most of the time, we don't even know it. Its DNA has been copied into some of the most popular languages out there: Python, Java, and even the modern heavyweights like Rust and Swift.
To really get how this happened, we've got to go back to the beginning. See, Haskell wasn't born in some big tech company. Nope. It was born out of a desperate need to bring some order to the chaos of academic programming.
So, picture this. It's the late 1980s. In universities, this new style of programming, these lazy, functional languages, is taking off. It was a cool idea. The problem, it was the Wild West. Everybody was building their own version. You had over a dozen of them, all just slightly incompatible. It was a mess, and it was holding back real progress. So a group of researchers decided enough is enough.
So in 1987, this committee gets together with one mission: create a single standard language that takes the best ideas from all the others. That led to Haskell 1.0 in 1990. But they didn't stop there. The language was carefully, deliberately refined for the next 20 years, leading to these super stable versions like Haskell 98 and Haskell 2010. This thing was built to last.
So what was the big deal? What were these game-changing ideas that made Haskell so different? It really all comes down to three core concepts that, for their time, were totally out there.
First up, Haskell is purely functional. And this is huge. It basically means that its functions behave like proper math functions. You give them an input, they give you an output, and that is it. They don't mess with things on the side or change the state of the world unexpectedly. The result, code that is incredibly predictable, no surprises.
Second is this thing called lazy evaluation. Most languages, you write a line of code, it runs immediately. Haskell, on the other hand, is, well, it's lazy. It won't do any work until the absolute last second, until the result is actually needed. It sounds a little weird, I know, but it lets you do incredibly efficient and powerful things, like work with infinite lists of data. It's wild.
And third, a super strong static type system. Think of this as the ultimate safety net. Before you can even try to run your Haskell program, the compiler goes through it with a fine-tooth comb and makes sure everything fits together perfectly. It catches a whole category of bugs before they ever get a chance to wreak havoc.
Now let's make this idea of purity super clear. Look at a pure function like square x. If you give it 4, you get 16. Today, tomorrow, a million years from now. It's predictable. But now look at an impure one, like read file. Who knows what that will give you? It totally depends on the outside world. Is the file there? What's in it? Haskell's whole philosophy is to force you to deal with that kind of messiness head-on. For a really long time, this was all seen as, just ivory tower academic stuff. But then, bit by bit, the industry started to realize that this obsession with correctness and predictability was exactly what they needed for their hardest problems. And just like that, these theories started leaving the lab for the real world.
So who's actually using this quirky academic language? Well, the list might just surprise you. Facebook, yeah, that Facebook, uses it to fight spam. The entire Cardano blockchain is built on it. Target uses it for complex supply chain logistics. And a ton of fintech companies like Mercury trust it to run their backends. We're talking serious mission-critical systems.
And here's why. This quote from Binomial, a company deep in the complex world of financial derivatives, just nails it. They say Haskell gives them huge leverage and lets them refactor, or change, their massive codebase with relative ease. That ability to change code without breaking everything is like a superpower.
And then you have Mercury, the startup bank, putting it even more bluntly. They use Haskell for correctness and security. I mean, when you're dealing with other people's money, you want a language that helps you eliminate entire classes of errors by design. It's not just a nice-to-have, it's essential.
Okay, so if Haskell is this amazing, why isn't everybody and their brother using it? Well, there's a reason the language has a reputation for being, let's just say, challenging. We have to talk about its infamous learning curve.
Hey, remember that lazy evaluation feature, one of its superpowers? Well, it has a dark side. Because the computer decides when to run the code, it can be really, really hard for a human to figure out how fast the program will run or how much memory it's going to eat up. That can be a huge headache for developers.
And then, oh boy, the error messages. This quote from a research paper way back in 2003 still rings true today. They called it a source of frustration among beginners because its power leads to these cryptic error messages. The learning curve isn't just steep. For a lot of people, it feels like running into a brick wall.
So all of this brings us right back to that central puzzle, that paradox we started with. Haskell is this tough language that very few people use, and yet its legacy is absolutely undeniable. It is the ultimate influential underdog. And here's the key takeaway, the big aha moment. Haskell's real impact was never about market share. Its true purpose was to be a laboratory, a clean, pure, perfect environment for testing out wild, radical new ideas in how programming languages could be built.
And what came out of that lab? Well, just a few ideas you might have heard of. That big push for safer, more advanced type systems you see in languages like Rust, the ideas of pure functions and immutable data that are all the rage now, even the clever ways that modern languages handle things like user input. So many of these ideas were born, refined, and battle-tested in Haskell for years before they ever hit the big time. It really is a ghost in the machine, but its fingerprints are all over the place. And that leaves us with this one really fascinating question to chew on. If Haskell was the lab for the ideas we all use today, what quiet, niche, maybe even academic languages out there right now are cooking up the ideas that will shape how we all code tomorrow? What's hiding in plain sight?